Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to be doing Unit 3, Part 7, Unit 3, Lesson 7. So don't forget to put your first and last name at the top right-hand corner of your paper, please. And today's topic is solving polynomial functions by factoring, Part 1. So we are going to be doing a two-part lesson. We're going to do Part 1 today and then Part 2 in our next class period. Today, you will solve degree 2 polynomial functions by factoring. So we're going to take what we've learned about factoring and apply it to some equations and actually use factoring to help us solve for x values. So if we go ahead and get started here, we've got some notes that we're going to write for ourselves about what degree 2 polynomial functions are. So a degree 2 polynomial function is also known as quadratic functions or quadratic equations. So when I talk about a quadratic equation, instead of having just an expression of ax squared plus bx plus c, we're going to turn this into an equation by setting it equal to y. So remember, a, b, and c are coefficients of x squared, x, and your constant. And then we have two variables now. Not only do we have our x squared, our x variable, but we also have y. So now we have an equation. Y is equal to ax squared plus bx plus c. So when I talk about solving these types of equations, there's some things that I need you to remember. So to solve, I'm writing to solve as one word. To solve quadratic equations, what I really mean by that is you're finding the x-intercepts. You're finding x-intercepts. So we're finding the values of x when y is 0. So whenever you have an x-intercept, whenever you talk about an x-intercept, you're always talking about a point where you find an x value and then y is 0. So for an x-intercept, the y value is always 0. So if you graph an equation that is a quadratic equation, if you graph y equals ax squared plus bx plus c, you're always going to get a parabola. You're going to get a graph that's shaped like this. It's either upwards facing or downwards facing. But you're always going to get a parabola. And when we solve these equations, what we really mean is you're finding the x-intercepts of these parabolas. So if you were to graph the equation, where would those x-intercepts be? And x-intercepts are the points where a parabola or a graph of any kind hits the x-axis. So here's my x-axis, and then here are the points where this parabola hits the x-axis. So when I talk about finding an x-intercept, I know my y value is always 0 whenever a graph crosses the x-axis. So what that means is whenever you solve a quadratic equation, you replace the y value with 0 and then solve for x. So you always plug 0 in for y and then solve for x. So 0 equals ax squared plus bx plus c. And then just another thing that you need to know is that x-intercepts are also called zeros. So x-intercepts are also called zeros. And the reason why is because they make the equation equal to 0. These points right here, these x-intercepts make those x values make the equation 0. Because the x values make the equation equal 0. All right. So you can solve a quadratic function in multiple ways. You can solve it by graphing, by factoring, by solving for x when you can. You can solve it by using the quadratic formula. You can solve it by completing the square. And we're going to learn all of these different ways to solve quadratic functions. Today's lesson is mostly focused on solving by factoring. Before we do that, I actually want to solve by graphing. So as you can see in example 1, this very first graph, it's already been graphed for us. Whatever the equation was, it's been graphed for us. And this graph in particular crosses the x-axis once. So that means that this function has one solution. Well, where is that point? That point, that one solution where it hits the x-axis is right here at the origin, or the point 0, 0. So our x-intercept is at 0, 0. And then our zeros, so there are two ways to write your x-intercepts or your zeros. You can write them as a point, and you can write them as what we call zeros. And when you do that, you write x equals whatever the x value is at that point. So my x value is 0. So that means that my 0 is x equals 0. Looking at the next graph. Well, again, this function only hits the x-axis one time, right there. And it looks like it hits it at, that would be 1, 2, 3. So this is 4, 5, and 6. So it looks like it hits the x-axis. We have one solution, once again, at the point 4, 0. So then my zeros would be x equals 4. So there are two ways to write the same answer. You can write it as a point, as an x-intercept, or you can write it as a 0, x equals 4. So why don't you give it a shot? So looking at this graph, tell me where our x-intercepts are. And in this graph, you should see that we have 2. So there are 2 solutions. There are 2 x-intercepts. Go ahead and write those x-intercepts as points. So the points you should have written are 0, 0 and 2, 0. Now, when you write the zeros, you're going to write x equals, and because there are 2 x values here, we have 2 x values. We have 0 and we have 2. You just put them as a list. You list them, x equals 0, and then a comma, and then 2. What this means is x equals 0 and x equals 2. All right. What about this last example? Here's our x-axis down here. Well, technically, this graph doesn't have any x-intercepts on the real number plane. However, it does have x-intercepts that are imaginary. We're actually going to talk about imaginary x-intercepts more in Unit 4 at the start of next semester. But for now, you just need to understand that there are no real solutions. There are no real solutions. So this parabola doesn't hit the x-axis on the real number plane. So you don't actually have to tell me what the x-intercepts and zeros are because you don't know how to find those just yet, because they involve the imaginary number I. So as you can see, we have 3 options for the number of solutions that a parabola can have. A parabola can have 1 solution, 2 solutions, or no real solutions. So in example 2, we're going to solve a quadratic function by solving for x. So what this means is y equals x squared minus 100. Well, anytime you solve a quadratic equation, you're always finding your x-intercepts. Well, for any x-intercept, y is always equal to 0. So when I solve a quadratic function, the first thing I always want to do is replace y with 0. So 0 equals x squared minus 100. Now solve for x. So we solve for x in the same way we would a regular equation. We want to isolate it. So x is being squared here. I want to isolate this x squared. To do that, I'm just going to add 100 to both sides. That way, negative 100 plus 100 becomes 0, or it cancels. 0 plus 100 is 100, so 100 is equal to x squared. Well, now I need to find a way to isolate x even further. Well, x is being squared. So what is the opposite of squaring something? How do I undo something being squared? I take the square root. So I take the square root of both sides. Well, the square root of x squared would simply be x equals. Now, when you square root a number, you technically always get 2 answers. So the square root of 100 is 10, but we technically have 2 answers where we always get positive and negative 10. Because if you go back to x squared equals 100 and you plug in positive 10, well, positive 10 squared is 10 times 10, which is 100. But negative 10 squared, negative 10 times negative 10 is also positive 100. So we actually have 2 values. Anytime you take the square root of a number, you get 2 answers. You get the positive and the negative. So we write that as positive and negative 10. Or you could write it as negative 10, 10. You could list them. So whenever you solve a quadratic equation in this class, you have to write your answers in 2 ways. I require you to write your answers in 2 ways. You're always going to write your answers as x-intercepts and as zeros. So your x-intercepts would be, in this case, negative 10, 0, and positive 10, 0. And your zeros then are x equals negative 10 and positive 10. So whenever you write your answers in this class, when you solve a polynomial like this, you're always going to write your answers as x-intercepts, as points, and as zeros. So now let's check and see if our answer is actually correct. And we're going to check it by graphing. So as you can see, I have brought up Desmos.com. Desmos.com is going to help us quickly graph the equation that we just solved. So if you graph y equals x squared minus 100, you should see a parabola that looks something like this. If I go out, you can see that my y-intercept is here, or my vertex, and then I have these 2 points. Well, where does this graph hit the x-axis? At 10, 0 and negative 10, 0. So we can see that our math was mathematically correct. Even though we didn't graph it, we were able to find the x-intercepts by plugging in 0 for y and solving for x. So now let's solve the next equation. Y equals x squared minus 16. Why don't you go ahead and try this one on your own? I'll give you a hint and get you started. So remember, the first step is to always plug in 0 for y and then solve for x. Remember, after you solve it, you are going to write your answers in 2 ways, as x-intercepts and zeros. Go ahead and press pause and then press play when you're ready to check your work. Give it a shot. So as you can see with my work, I solved for x and I got x equals positive and negative 4. So my x-intercepts are 4, 0, negative 4, 0, and my zeros are x equals plus or minus 4. Right, and let's do the last one. So part C, y equals x squared plus 9. So of course we plug in 0 for y, and then we solve for x, but this time we have to subtract 9 to both sides. And we get x squared equals negative 9. Well, we're going to run into an issue with this problem. When I square root both sides, well, I'm square rooting a negative. And as far as we're concerned, plus or minus the square root of negative 9, we get 2 answers, of course. As far as we're concerned, at this point, we can't take the square root of a negative just yet. We haven't gone over that in this class yet. So because we are square rooting a negative, we end up with an imaginary solution. So this means that we have no real solution. Our x values, or our x-intercepts, will end up being on the imaginary coordinate plane. And we're going to go into imaginary solutions more in depth, like I said, in Unit 4. So for now, you're just going to have to trust me. When you end up with a negative under your radical, you have no real solution. All right. Now we're going to jump into the fun part of the lesson. Example 3, solve the quadratic function by factoring. So as per usual, I've got our steps listed out for us, so it's really easy to follow along. And we're going to go ahead and jump right in. So step 1, to solve this quadratic function by factoring, the first thing we do, step 1, is set the equation equal to 0. So replace y with 0. Then you need to factor the degree 2 polynomial. So we need to factor the right-hand side. So 0 is equal to, well, all right. So to factor, remember a was 1, b is 24. 1 times 24 is 24. My factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those factors add or subtract to get us that negative 11x? 3 and 8. So we would rewrite this as x squared minus 3x minus 8x plus 24. And I know they both need to be negative because negative 3 minus 8 is negative 11. Then we put our parentheses around the first two terms. We want a plus sign in between the parentheses around the second two terms. Then we factor out the GCF. So 0 equals x times x squared. Just kidding. That would be x minus 3. We're going to factor out a negative 8 because our leading coefficient is negative. And we're going to have x minus 3. Well, hey, our parentheses match. So we get 0 equals x minus 3 times x minus 8. And that's our factor form. All right. So the only thing that's changed is that because this is an equation, it's set equal to 0 at every step. So make sure you have 0 equals out in front of every step because it's still an equation. We just factored the right-hand side. Now, step 3 is to set each factor equal to 0. Ooh, I actually forgot something here. Set each factor equal to 0 and solve for x. Sorry about that. Set each factor equal to 0 and solve for x. So let's review something. X minus 3 is a factor and x minus 8 is a factor as well. So you take each factor, x minus 3, and set it equal to 0. Then you take the other factor, x minus 8, and set it equal to 0. Now solve for x. So add 3 to both sides, x equals 3. Add 8 to both sides, x equals 8. So what we've just done is we found the x values of our x-intercepts. Well, our final step is to write our final answer as x-intercepts and zeros. So my x-intercepts, my zeros. My x-intercepts are at 3, 0 and 8, 0. My zeros are x equals 3 and 8. When you do your homework on MathXL, MathXL wants you to write your final answers as zeros. So you're going to enter x equals 3 and then comma and 8 for your final answer on MathXL. I'm pretty sure that's right. Let me know if I'm wrong. All right, so let's double check that we actually found the right answer. And let's see if the graph of this equation, y equals x squared minus 11x plus 24, agrees with our mathematic reasoning here. Give me just a second to pull up that graph. So I'm back on Desmos.com and I'm just gonna check to see if my math was correct. We're gonna graph y equals just kidding, y equals x squared minus 11x plus 24. Well, hey, I've got an x-intercept at 3, 0 and 8, 0. So we were right. We did a really great job. We were able to correctly solve this function by factoring. All right, let's do it again. All right, so y equals x squared minus 10x plus 24. So I'd like you guys to actually do step 1 and step 2 by yourselves. Step 1, replace y with 0. Step 2, factor that right-hand side. Go ahead and give it a shot. Press pause and then press play when you're ready to check your work. All right, so as you can see, step 1, 0 equals x squared minus 10x plus 24. Then I went ahead and factored it, and I got 0 equals x minus 4 times x minus 6. And make sure, again, that you have 0 equals at every single step. I am really picky about that when I grade, and if you don't show that in your work, you're not going to get credit for it. This is an equation, and we need to keep that equal sign in there to show that it is, in fact, an equation. All right, step 3. So step 3 is set each factor equal to 0. So one of our factors is x minus 4. Set that equal to 0. The other factor is x minus 6, set that equal to 0. Now go ahead and solve for x in both of these, and then write your final answer as x-intercepts and zeros. Press pause and then press play when you're ready to check your work. So I got that my x-intercepts are at 4, 0 and 6, 0, and my zeros are at x equals 4 and 6. All right, why don't you go ahead and try a problem on your own. Actually, for this one, I'm gonna have to give you a little hint. So x squared plus 7x plus 15 equals 5. In order to solve a quadratic equation, we need this to be equal to 0. Right now it's equal to 5. How can I change that? How can I make 5 become 0? Well, I'm sure you guessed it. We just subtract 5 to both sides. When I subtract 5 from 5, I get 0. And then on the right-hand side, x squared plus 7x plus 15 minus 5. 15 and negative 5 are like terms, so I can combine them. So I leave x squared and 7x alone, those don't change. But 15 minus 5 simplifies to 10. All right, go ahead and factor that. Set each factor equal to 0 and then solve for x. Write your final answer as zeros and x-intercepts. Press pause and then press play when you're ready to check your work. So as you can see through my work, I was able to factor this polynomial to x plus 2 times x plus 5 equals 0. I set x plus 2 equal to 0. I set x plus 5 equal to 0 and solved for x in both. I got x equals negative 2, x equals negative 5. I rewrote my final answer as x-intercepts, negative 2, negative 2, 0, negative 5, 0. And then as zeros, x equals negative 2 and negative 5. All right, go ahead and do part D completely on your own. So solve 7x squared minus 14x equals negative 7. Go ahead and go for it. Just press pause and then press play when you're ready to check your work. All right, so let's talk about this problem. So I added 7 to both sides, as you can see. And I got 7x squared minus 14x plus 7 equals 0. Then I noticed that there's a GCF of all three of these terms of 7, so I factored a 7 out. Then I factored what was left, and I got 7 times x minus 1 times x minus 1 equals 0. Well, what I noticed was these two factors are the exact same. So x minus 1 equals 0, and then x minus 1 equals 0. When I solve for x in both of those, I get x equals 1 and x equals 1. So because of that, I know that I only have one solution. I only have one x-intercept, and that's going to occur at 1, 0, and my 0 is at x equals 1. So even though it happens twice, you only have to list it once. One other thing I want to talk about real quick is up here. So one of the factors is 7. 7 times x minus 1 times x minus 1. Well, the reason why I didn't have to do anything with this is because if you divide both sides by 7, 7 divided by 7 is 1, and 0 divided by 7 is 0. So we can kind of just pretend like that number doesn't exist because it doesn't have an x attached to it. So it doesn't impact our x-intercept. If there was an x attached to it, that would be a different story. All right. So that's it for today's notes. Actually, you know what? That's not it. I wanted to do an extra example. So let's do part E. So this is still part of that example. You can just throw it on the back of your paper if you're doing your notes on the guided note sheets. Let's do part E. So what if you saw an example like x squared minus 7x equals 0? Well, because x squared minus 7x equals 0, the factored form of this would just be factoring out the GCF. The GCF of x squared and negative 7x is x, so we'd have x times x minus 7 equals 0. So the steps are still the same. You take each factor, x and x minus 7, and you set them equal to 0. So x equals 0 and x minus 7 equals 0. What this means, though, is that you have an x-intercept at x equals 0. There's nothing to solve here. X is already equal to 0. But you have to include that as a solution. That means that you have an x-intercept at 0, 0, and 7, 0. And then your zeros are x equals 0 and 7. I just wanted to show you a quick example like that because I believe there's some on your Math Excel homework tonight. All right, so go ahead and do the extra practice for today's class, and I'll see you back in class.